CAPI. I'll go ahead and introduce my guests. We'll get started here pretty quick. I'll introduce. So I had Anmol on last time. Let me put Pushkar on the left. I had Anmol on last time. This time I've got Pushkar. So we'll introduce Pushkar first. How's it going, Pushkar?
Doing good. How about you?
Here. Pretty good. All right. So what do you do at Platform 9? What's your role and title, and what do you work on?
So my name is Pushkar. I work as a staff engineer at Platform 9. I have been here for close to 9 years. I started as an OpenStack engineer, worked on VMware integration, public cloud integration with OpenStack, then moved into core services, and recently started working with the Kubernetes offering from Platform 9. And the most recent work is building CAPI support in our product. Yeah.
Awesome. Yeah, I think a lot of people that come into Kubernetes started out with OpenStack. That's my journey too. Is I went into OpenStack and then Kubernetes or containers, and then what's this new thing? Kubernetes. That makes it even easier. Like Docker, using Docker compared to giving like a developer a VM was groundbreaking. Like it was so amazing for how fast I could actually like test things and do things compared to like, oh, I got to stand up Vagrant or I got to use OpenStack and deploy like a VM that's going to take a few minutes. Right. All right, let's go to Anmol. So Anmol, what do you do here? Let's introduce you again.
Hey everyone. Yeah, busy morning this day, but yeah. My name is Anmol. I work as a product manager at Platform 9. I take care of all the Kubernetes stuff we have. And prior to this, I started my career in storage, actually at Cluster, and then moved on to Ceph storage, and then the whole Kubernetes shebang happened, and then we were like, okay, we got to move this to Kubernetes, and then move to Rook, Ceph storage on Kubernetes. And now here I'm at Platform 9.
It's awesome. It's great to have you too. So if you stay tuned till the end, I'll give you some information about seeing us at KubeCon. But let's go ahead and start talking about CAPI. So we've got background. Pushkar's our engineer. Anmol's our product manager. So they work together on implementing this and getting this into the product. But let's talk about it kind of in a vanilla sense to begin with. So we'll start with you, Pushkar. What is CAPI? What is Cluster API?
So Cluster API is basically a collection of custom resources. And just to give you a brief idea of what custom resources. So resources are a collection of objects in Kubernetes, and custom resources is the way you can add your own resources to the declarative style of Kubernetes APIs. So CAPI is a bunch of these custom resources that allows you to manage the lifecycle of a cluster. So you can use Kubernetes to manage other Kubernetes clusters. You can create them, manage them. Management includes upgrades and all of those. And then you can also delete them. So CAPI takes care of creation of VMs, the networking infrastructure, any storage infrastructure if needed, and then configures the Kubernetes components on these VMs or other infrastructure that you might have, and gives you a cluster, a fully functioning cluster.
So Anmol, why do businesses care? Like, I'm a business. Like, what do I care? Why do I care about this? What does it do for me?
All right, let's give them a background first. So Cluster API, as Kubernetes, as Pushkar said, that started as a special interest group project in Kubernetes community itself in the SIG lifecycle. So the way it started is because a lot of companies, the big hyperscalers, they were developing their own infrastructure as code, right? Now they saw that they're doing the same thing but in their own silos, right? And then there's a need to. And when it comes to Kubernetes is a common layer, right? It's a layer that sits on top of your infrastructure as a code. So they saw the need that to run Kubernetes on any infrastructure, you need a common abstraction over all of these infrastructure providers, and it needs to be Kubernetes native, right? So basically, you can declare your infrastructure as Pushkar said as custom resources. Simple custom resources. Once you do that, your VPCs and stuff will come up. So why business should care about it, right? So it gives you a good abstraction onto a lot of multi-cloud hybrid on your hybrid journey. So you can create a cluster on AWS at a moment, then go on to GCP, go on to Azure, right? You have a single platform to do it, right? And then it's vetted by the hyperscaler itself, so they have all the native features that you would need. to support your developers or your dev productivity, right? So I think that's one of the primary reasons that should be done. And over that, as a company, you can develop on your own layer of it. So probably that would be a good reason to start with it.
So do you think like most people are implementing this in like a vanilla way to where it's just like it's always the same everywhere, or is it going to be? You think this will turn into something like different ingress controllers that are going to have different annotations and stuff with them, right? Like, what do you see happening? We'll start with Anmol, and then we'll go back to Pushkar. Like, do you see that everyone's got their own version of CAPI, or is everyone going to use this vanilla version so it's the same everywhere?
Yeah, so I think the way it has happened is like the community has tried to maintain one core repo called CAPI or Cluster API, and then all the infrastructure providers, they went on their own way to actually plug into this main repo. So that's how it works. So the support for infrastructure providers has been ever increasing. Now you have at least I think 16 to 18 infrastructure providers today. So that I think gives a lot of business value to people.
What do you think, Pushkar? You think that it's just going to be adding providers instead of adding like their own version? That's what it looks like it's going to now, like almost.
That's what it looks like right now, because CAPI is very modular. It provides you a way to create add your own infrastructure provider and something called as a bootstrap provider. So infrastructure providers allow you to create different infrastructure, networking, VMs. If you already have your own existing infrastructure, there are providers that will allow you to plug that into CAPI as well. And on the other side, there are bootstrap providers that provide you a way of how do you configure the infrastructure once it's built up into and convert that into a Kubernetes cluster. So you have the default implementation with kubeadm, but there are a few others out there that allow you to create your own, like you can have your own way of bootstrapping a Kubernetes cluster on an infrastructure. So CAPI in general provides you a lot of modularity where you can, instead of having your own version of CAPI, you can just add to the existing infrastructure and existing cloud providers. Yep.
Well, awesome. All right, so we've talked a lot about custom resource definitions. Maybe we'll expand on that a little bit before we go further into CAPI. What is that, right? Like to my understanding, it is a controller and a reconciliation loop, but
Yes.
it'll translate things into Kubernetes resources for you or connect to maybe outside APIs or something like that to create stuff for you. I think working on Knative and stuff, right? Like Knative is just a way to abstract a bunch of Kubernetes resources, right? So what's the, I'll say this first. So Pushkar, how many days after using Kubernetes did you install your first CRD, right? Like did that expand your expectations of Kubernetes? Like that kind of show Kubernetes something completely different than you thought it was when you first started out? Like it's not just a container, management type thing. It's a development platform almost.
Yes, it actually nowadays folks will call it as Kubernetes as an OS, a cloud OS, right? And that's because of the functionality, the extensibility of the Kubernetes platform. And CRDs are a core part of that functionality. It basically allows you to add your own APIs on top of the existing APIs, and then you can implement your own, like you said, the reconcile loop. You can implement your own controllers to make those APIs a fully functioning declarative API in Kubernetes. It can be as simple as, okay, I want to create a VM in AWS. I can add a new API, a new CR custom resource, write a controller in the back, and that actually connects to the CR and creates the VM in AWS. It can be as simple as that. And on the other side, it can be as complex as deploy a full-blown application which has like 4 different pods and 5 different services, whatnot. So you can go from something that's very simple to all the way that's like CAPI is a custom resource. So you can go from creating a VM to creating a full-blown Kubernetes cluster using these custom resources.
So I'm gonna get your answer here in a second too, Amal, but what does that do for a user? Like what does that change for my users, right? Like I'm just giving them Helm charts or something like that, and then they just like describe what they want and they can just get stuff deployed, so they're never touching infrastructure or Terraform or like any of these things. Like what does that do for my users?
Yeah, exactly. That's correct. And one of the things is the Kubernetes is the declarative APIs versus what most of us have been used to with OpenStack and others as was the imperative APIs. What I mean by that is instead of telling how you do this, I'm just telling Kubernetes, hey, this is the state I want to get to. And it's the job of the controller and the developer who has created that controller to make that happen. So now, as an end user, I don't have to worry about, oh, how is this going to plug into my infrastructure? How are they going to get it done? I don't have to tell that to the APIs, tell that to the server. That's already taken care of. I just have to tell the end state that I want to achieve.
All right, Anmol, let me give you a chance.
Yeah. Yeah, I was listening to Kelsey Hightower this morning. I was like, and there was a very awesome analogy that he said. Okay, so I'll bring that to the users, and it just made me was like, wow, that's a great one. So let's say Christmas is coming, right? You want to send a lot of gifts to your friends, right? And those gifts are not going to be the same. They're going to be in different shapes and sizes, right? Now you want to package these gifts in an envelope and you want to send it to them, right? So you'll write their name and address and their contact number, and you'll put a stamp and you'll give this to the post office or FedEx, whichever way you want to send it to them, right? So, and then the post office gives you a guarantee that, hey, I will deliver your package in 3 days or 2 days, right? So coming to the Kubernetes analogy, this package which you're sending and you're writing a top layer of it, right? You're writing the address and everything. That's a Kubernetes CR basically, where you write what you want and where it needs to be delivered. And then the post office or FedEx is actually the carrier or Kubernetes, which actually makes it happen. And you do not, once you give it to them, it doesn't care anymore where it needs, like you don't, as a user, don't care how it will happen. They say they will ship it by train or plane. You don't care. It will be delivered where you need it to be. So that's how I see CRDs as well.
It's a pretty cool analogy. All right, let me go on to the next part. All right, so we talked about CRDs. So we'll start with Anmol. What do I need to get started with CAPI? Right, like, so you've implemented this a bit with the with Platform 9. So what do I need to get started? Do I need a management cluster? Like, how do I get started?
So Cluster API is basically a bunch of controllers. So you'd absolutely need a Kubernetes cluster. So you would need something called as management cluster, which you spin up, right? And you install Cluster API controllers on it. And then you just write your cluster definitions on it. And the moment you hit a kubectl apply, what the controls will do is they have different jobs. One controller will talk to, let's say you're trying to create an AWS cluster on AWS, it'll talk to AWS, get your VPCs running and everything, get your subnets ready, get your NAT gateway ready, and responds back that, hey, the whole infrastructure is ready. Now you deploy your EC2 instances on it, and then there comes the bootstrap provider, which actually starts bootstrapping your nodes and makes them actually a Kubernetes cluster. So that's how it happens in Cluster API.
All right, Pushkar, got anything to add to that?
Yeah, I mean, no, he has covered everything. You just need an existing Kubernetes cluster. It can be something that runs on your laptop, like Kind or Minikube, or it can be a cluster that's running in somewhere in AWS or any other public cloud for that matter. And yes, obviously, you need the credentials. You need to provide credentials to this management cluster so that it can orchestrate all of this creation on whatever public cloud or something else.
So the next fun question is then, how do I manage the management cluster? Right, like you're saying Kind, but like if I've got like a full-on cluster, right? Like, is there a way to manage that with CAPI, do upgrades or anything like that, or am I kind of like managing this on my own? Like, is there like a little loop that'll take care of it for me, or?
So the vanilla documentation and implementation says that they recommend that you create a bootstrap cluster first, which generally would be Kind, because that's something that you can create out of box. So you create a bootstrap cluster. From bootstrap cluster, you install CAPI on it to create the first management cluster. First cluster, which you then convert into another which you convert into management cluster, and from this management cluster, then you start creating other workload clusters. So the bootstrap cluster, yes, you're still responsible for upgrades of it. You're still responsible for managing the CAPI components on it. But the upgrade of your, what you can say, you can call it as a production management cluster, that can be managed through this bootstrap cluster now.
That makes sense. So I guess say I'm using Kind, right? Like,
Yeah.
if I'm using Kind and I've got my configurations and stuff saved in GitHub or somewhere else, then I could just load up a new version of this with Kind whenever I want to create like another cluster. Is that kind of like that? Is that the workflow, or like what's the workflow of, oh, I need to create more clusters, or I need to upgrade my management cluster? I can have it running Kind and upgrade the management cluster there with a new version of CAPI, or that's too complicated.
Cluster CTL actually, Cluster CTL is a CLI from that you can use to interact with all these CAPI components. It implements a simple API. It implements a simple command line arguments by which you can upgrade the CAPI components themselves. So it's something called as Cluster CTL upgrade, and that command will take care of generating a plan for you as to how these components will be upgraded, what API changes might be needed. And you can schedule a rollout as to, okay, I want to roll out the upgrade now, or something like that. So that is there, but you're still responsible for making sure that your Kubernetes version is compatible with your CAPI version and vice versa. Like for example, to create a 124 Kubernetes cluster, to create a 124 Kubernetes workload cluster, your CAPI components need to be at the latest version. But to run the latest CAPI version, your the management cluster on which those CAPI components are running, it itself needs to be at version 124. So there are other although it's very simple to upgrade your cluster using Cluster CTL, and even to upgrade your CAPI components, it's pretty straightforward. But you are still on hook to make sure that all these underlying, what you can say, nitty-gritties are sorted out.
So Anmol, what does that look like creating a product, right? Like, does that make it easier for you to upgrade or manage other clusters, like within our product, but even like any product out there? Like, does it make it easier to create and manage stuff?
Yeah, absolutely. I think whenever you're creating Kubernetes clusters, it's easy enough to do it like 1 or 2 clusters, right? But when you want to do it on a scale, let's say you want to create 20 clusters and want to maintain them in production, that is where the value of Cluster API comes in, right? So you just need one management cluster to orchestrate all of these 20 clusters and spin them up, spin them down whenever you want. Basically, you can treat your clusters as kettle, and whenever you want to do whatever with them, you can do it. And the amazing part is with CAPI that in the individual cluster as well, you have concepts of kind of node groups or machine deployments, machine pools. There are different CRDs there, so you can scale them up and down individually, right? So maintaining your bigger infrastructure on a scale, that is when CAPI gives you the real power of it. And as Pushkar was saying, that the versioning thing about the management cluster and the matrix with CAPI, yeah, that's a given. I mean, even if you write some Terraform scripts tomorrow and you have to you still want to create those 20 clusters, you'll have to do the same change in your Terraform scripts as well, right? So that's the analogy. But the good part with Cluster API is that you don't have to write a new Terraform script for every provider. It's just one single layer to do everything, and you can just define your CRDs and it'll do everything for you. And there's another nice feature that's in Cluster CTL, that you can transfer ownership of workload clusters from one management cluster to another. So let's say you want to refresh your management cluster, you can transfer that ownership to another management cluster, and you can just move it from one cluster to another. So you could do that as well. So that's another use case which Cluster API provides people.
That's pretty cool. That seems it makes it like it's easier to upgrade then without having to worry about that going down, or like say it broke, you can just stand up another one and you're not going to lose all your cluster information or all the information about the clusters already deployed. All right, so move on to the next question. So I see a lot of providers in the documentations for Anmol. For Platform 9 specific stuff, do we plan on adding support for additional infrastructure providers? Right now, I think we're doing EKS and AWS. Are we adding more in the future?
Absolutely. We have recently rolled out AWS and EKS, and we are going to support more hyperscalers like Azure, EKS, and then even GCP and GKE in future. So that's on the roadmap already. And then we'll probably, the way Platform 9, the value that Platform 9 is trying to provide to users is going on their hybrid cloud journey, right? So it's not just going to be just hyperscalers. We will be trying to add support for your bare metal as well. with Metal 3, and then you have KubeVirt as well, like creating clusters on top of KubeVirt. So there's a lot of providers that are on the way. So yeah.
There's a lot of huge value with that, right? Like all the projects Metal 3 and Metal LB and stuff to make it easier to do bare metal and on-prem. Like that looks awesome. Does CAPI makes it so as a product manager and like creating a product, does CAPI make it easier to add additional providers if they're supporting it compared to like having to write it all yourself?
Absolutely, right. If you had to write your own new provider for every infrastructure provider out there, you first have to go and understand their infrastructure provider. You have to understand their APIs, right? Then you build your own layer in between. What CAPI does it is basically you have a central CAPI, you just take another infrastructure provider, their repo, and you just plug it in here, and that's all you have to do if you're doing if you're doing DIY, right? For making a product out of it that we're doing today, it's a little bit of more exercise, but it's way easier than writing your own infrastructure provider. It gives you an edge of probably months as well. So yeah.
Wow. Yeah. Having a agreed upon API instead of having to monitor and see updates to their API every time and change stuff that you're working on with every release is probably a lot better too.
Yes.
So let's get a Pushkar. Oh, Pushkar, you can.
Having worked on the CAPI stuff in the last 2 months, so one thing that we have done is, so we have our own project called as Nodelet, which we have converted into a bootstrap provider. So now what we have been able to do because of the extensibility of CAPI is we were able to take the infrastructure pieces from the existing infrastructure, AWS infrastructure provider, and still use our own bootstrap provider with the existing stuff. So we didn't have to build out the entire infrastructure provider just to get our components working through CAPI. So that's the extensibility of CAPI that we get to enjoy.
That's awesome. All right, so this one's for Pushkar. So does it support more complex configurations like multiple networks and like CNIs and that kind of stuff, right? So if Metal 3, it's supporting that. Like this is probably maybe originated with like cloud providers, but now like people are looking at this as, hey, I can do automation on-prem and locally or like at the edge. Does it support like those complex configurations for like CNIs and maybe even like adding KubeVirt and pass through and that stuff?
So a bunch of these, I mean, I don't have the exact answer to your question. When it comes to CNIs, by the vanilla cluster that comes up, it doesn't actually have a CNI. You can install whatever CNIs you want on top of this workload cluster that was created through CAPI. There are some providers which will provide you an out-of-box CNI. Like from AWS, you have something called as a VPC CNI that you can just on their custom resources, you can just say that, yes, I want the VPC CNI to be enabled, and VPC CNI will be installed when the cluster comes up. So as far as CNIs are concerned, that's the approach that CAPI has taken. It's left to the user, it's left to the infrastructure provider and the bootstrap provider to implement that. We at Platform 9, we generally install Calico as a default CNI always, so that when the cluster comes up, it's fully functional. Without a CNI, cluster isn't really functional. You can't really use it.
So that might be a surprise to users, right? Like they've created this cluster and they're like, wait a minute, now what do I do for networking, right? Like what do I do? I have to do this after the fact. But I guess that's taking an approach of like hands off and not opinionated,
yes,
right? Like you can just do whatever you want. We're just going to set stuff up for you, but you still have a little bit of extra things you can do, right? Like where stuff like Luigi and other like CRDs can help install that stuff.
Yeah, Luigi is a very great example. Once you have a bare bones cluster ready, you can install Luigi, you can install Malta CNIs, you can install Flannel, Calico. There are 5 or 6 production ready CNIs out there that you can just deploy on based on your needs. Yeah.
Anmol, do you want to add anything? I know I was asking Pushkar that one.
Yeah, sure. Yeah, I think as Pushkar covered it well, that CNI usually is responsibility of the users to put on, right? And I see it as the capability of your infrastructure provider as well, right? So on physical nodes or VMs, you can use Calico, Flannel, whichever you want, right? But let's if you go on to now the cloud, right? So if you look at AWS along with the normal subnet IPs, they provide secondary IPs as well, right? So supporting those secondary IPs that might not just be a use case for Calico. But then AWS comes in there and they say that, hey, we have AWS VPC CNI that helps you utilize these secondary IPs as well. And the great thing about CAPI is that, I mean, it doesn't stop you from doing anything. It gives you a bare cluster and you can still install anything which you want. For our users, what we're doing is we're allowing them to install Calico or AWS VPC CNI, whichever they want, on the AWS clusters. And for EKS clusters, we are supporting by default the VPC CNI itself.
Awesome. So here, I'll go to Pushkar for this one first, and then I'll come to Anmol. So we kind of touched on it, but I noticed like Metal 3 is a provider. Does that mean I can automate bare metal provisioning, cluster creation on premises? Have you started playing around with that at all yet, or have you mostly focused on cloud stuff, or like
No,
cloud
yeah, I
providers?
mean, I have mostly focused on the cloud stuff at the moment, but I did take a brief look at the Metal 3 provider. Yeah, it looks like you can actually take bare machines and convert them into a fully functioning cloud from start to end. So the machines will pixie boot, and once they pixie boot into a particular OS, then the bootstrap providers will take over to convert those machines into a fully functioning Kubernetes cluster. But what that also means is you need to have a fully functioning ironic deployment, which can be plugged into this CAPI as a provider, which I frankly, from my OpenStack days, isn't as straightforward as CAPI.
So Ironic's still alive, right? Like it's still pretty popular. It's crazy. Like after all this time, Anmol, have you started messing around with any bare metal stuff around prem, or are you mostly focusing on AWS, EKS, and cloud provider?
It's part of the job to look at a lot of things. So I did try to look at it. So basically, I see there. I see it as two layers there. So once you have your bare metal nodes, now you have, as Pushkar said, you need a layer. You need a layer that talks to these bare metal nodes. Once that happens, that is where the cluster API comes in now. So anytime you want to create a new cluster, you just say how many nodes you want, and it will provision it for you. You say I want this operating system. So the lower layer will bootstrap your machines with whatever operating system, with whatever configuration you want, and then CAPI just comes in and this deploys your Kubernetes cluster on top of it. So even if you look at it, if you're looking at a scale of 1,000 to 1,000 nodes, and you want to create multiple clusters out of it, I see a lot of value that CAPI can provide here. Because otherwise you have to, every time you have to create a new cluster, you have to create a new ignition config or something, right, for different people, and then you have to then deploy it, and then it goes off to do its job. But whereas with CAPI, you just create one template, say I want 5 clusters of this template. It'll be ready for you in a moment.
And the nice thing is be able to like reconfigure your infrastructure pretty quickly if you've got changes in your requirements, right? Like you're like, oh man, we were giving developers their own Kubernetes cluster. It's like, well, maybe we'll just do like multi-tenancy and just get rid of all these and make a couple of like larger clusters, right? Like I think people are still figuring out what's better, a single cluster, big cluster, well, super big cluster, have everybody share it, right? Like my previous job, that's what we're always wondering too. It's like, well, we've got like, 20 or 30 Kubernetes clusters. Can't we just get everybody on one? And that didn't work out too well either, because all the developers wanted to do their own little thing, install their own stuff, and have full control. Let's go. All right, let's go on to the next thing. So you kind of touch on what you already talked about, Anmol. So what are some of the bigger limitations besides, I guess, maybe the Ironic and Metal 3? Are those the biggest limitations you think for on-prem compared to cloud providers, right? Like having to build kind of that layer yourself, where you have to get a node installed with Ubuntu or installed with CentOS and then available and ready to go, or Red Hat?
Yeah, I think that's it's not a limitation as per se. I mean, if you want to have the control on your nodes, that is where it comes in, right? Otherwise, you would probably put a layer of a hypervisor or something in between, and then you just create VMs on top of it. So I wouldn't say it's not as straightforward as using it on cloud, but bare metal has always been difficult. So it still makes it much easier than your normal bare metal life cycle today.
There's a VMware provider too, right?
Yeah, there's something called the bring your own host provider from VMware, which allows you to take any VM and register that and allows you to use that VM as something that you can configure your Kubernetes cluster on. it's actually implemented as a infrastructure provider, so you can use that as the infrastructure provider, and then use any other bootstrap provider to create your Kubernetes cluster on top of those nodes. Now, using that, something like that means that you have taken away the infrastructure part of CAPI away from CAPI. Basically, you're managing your own infrastructure. You're creating the VMs. You're creating those bare metal machines, and then installing this bring your own host provider on top of it to bootstrap it into something that CAPI can use.
Sounds like it's still more work. It's more work than just using, like, say, a cloud provider or something like that, where you just say, I want this, and then they go deploy all of the VMs and stuff for you. All right, so we'll go Pushkar for this one. So what are some of the benefits? I think we've touched on all these questions I have. We kind of talked about a little bit more, but I'll do a little bit targeted. What are some of the benefits of being able to manage your Kubernetes clusters like you would a Kubernetes resource? Like what are some of the interesting things you've seen or that you're excited about with CAPI?
So the biggest advantage that I personally have seen is being able to. So one thing is that now I have one template, and I just change the name of the resources, and there you go. I can replicate my cluster from one cloud provider to another cloud provider, or just create multiple of the clusters with just kubectl apply. So basically the consistency of the deployment and being able to repeat that same deployment, and knowing that so long as I have my cloud budget under control, I am able to deploy it, works perfect, right? I mean, that's the dream in a way. It simplifies so many things. I don't have to worry about making small changes to make sure every time my cluster deployment works fine. All of that is taken care of.
So it sounds like I could do something like maybe I'm doing like machine learning or something like that, and I've figured out exactly, like, I can test on bare metal locally, maybe doing like inference or something like that, not doing training, but I figured out exactly what I need to make sure that I can run this in the specified amount of time that I want, and I'm doing it all on bare metal locally. But now I want to scale it up to have it run multiple times in different places. I can kind of figure out what is the bare minimum that I need so that I'm doing just enough and I'm not doing way too much. And that's what you're saying, like template it out. I've templated it out for my local infrastructure. Now, I can just deploy that on Google or Amazon and have exactly what I need, because you need to have a good amount of claims and resources available to be able to run some of these workloads. Like, that's kind of, I guess, one of the benefits you're saying too. That'd be like a good use case maybe.
Yes. And also, like you said earlier, right? You can stick all these configurations in GitHub. Yeah, and now you can just download it from GitHub, make some modifications, and get it working. And I believe that you can do the same with, I'm not sure, but Argo CD might also be something that Argo CD or a Helm chart, you can convert all of these into something like that to simplify it even further, where you're not even having to run all these kubectl commands to do YAMLs and YAML applies and whatnot. So you can leverage all these open source projects to further enhance your GitOps journey.
So Anmol, tell me about Arlon then, right? Like, that's what we're kind of moving into. It's like with this, it opens up the ability for all these other projects to do more, right? Like, tell me, how do I do more? How do I do more with?
I was coming to that. So Pushkar just touched upon it, the GitOps thing, right? So GitOps has been kind of a front runner now in the whole DevOps community and in the DevSecOps community, right? Now people don't want to touch their production clusters or their production anything. Whatever they want to go in production, let's say apps or anything, they want it to be done through GitOps so that they have the control, they have the security there, and they have a visibility of what happened. And if something is not what it should be, it's reconciled back to what it should be into that state, right? So this happens today with GitOps for applications. Let's say you want to deploy an application, you do it through Argo CD, and you deploy that application on a cluster, right? Now, what CAPI helps you do is templatize your clusters into custom resources, which Argo can understand now. And you can now use your Kubernetes CRDs in form of cluster. And you can give this to Argo, and then Argo now can go and deploy take this 8 or 10 manifests and then deploy a cluster for you, right? And if you want to deploy 100 cluster with probably one click, you can just actually do it. That's the power that it brings you. And I like to call it something called as cluster ops. So it's just a higher version of GitOps. So you can do actually cluster ops now with Cluster API and any something like Argo. And this is where we saw the value of Cluster API and the whole ecosystem of CI/CD. And then that is how Ardlon came into the picture, and the idea for Ardlon came in. And now the Ardlon is actually open source for everyone to use. So yeah, that's how it happened.
So you're getting, engineers are excited. The people who actually have to sign the checks to pay for this afterwards, like, oh man, I get deploy 100 clusters out of nowhere, like based on this one thing. It's kind of scary, right? But that's also pretty exciting, I think.
Yeah, and as an engineer, right? If you as a cloud native engineer, I develop containers every day. I want to test them, right? Now, sometimes you can test them in a local system, but sometimes you have to test them on a Kubernetes cluster, and you can't just ask anyone for a Kubernetes cluster. They would, I mean, you need to have your own. So this makes it so easy that you just create actually a Slack bot or any bot, or just put just a command there, and you just hit that command, and in 15 minutes later, you have a cluster ready for you on bare metal, Azure, Google, wherever you want. And then you just say another command, and then your cluster is away while you're going home. And that's it. And that's your everyday developer journey for you.
I see something like KubeCost coming in to that picture too, to where like I can start doing chargeback to people when they actually use their clusters, right? Like I've got this whole system like, oh, your department, I'm going to charge you this for that. Do you have anything you want to add, Pushkar, to that, or?
Oh, he covered it very well. Like the cost aspect is something that I think comes up quite a lot when it comes to creating clusters, especially in public clouds.
Yeah, but this saves cost as well, right? So earlier back in the day when I used to write a lot of this Kubernetes code, right? I had to leave my cluster running all the time, like the whole week or the whole month, because I don't want, because bringing it up and bringing it down was a painful journey of at least an hour, and then waiting for it, and then I don't want it. So now what you can do is just provide your configurations, and 15 minutes later you have your clusters ready, right? So it actually saves cost, a lot of cost. You see,
that's a great point. Yeah, because I've done development for like Knative where having a cluster up all the time made it very helpful, because I'd have a load balancer and that kind of stuff before Metal LB and everything was on the scene. And then like after moving to that, like, oh, we got to cut down a cluster, so we started using Kind, like where I would run into issues like I can't do everything that I want to do with Kind. I've for the most part it's there, like I can run tests and that kind of stuff. But the ability to launch your, say, Monday morning, 15, 20 minutes, however long it takes your provider to actually stand that up, some are longer, some are shorter. You've got a script running saying, hey, go deploy this for me. And it's 15 minutes before you start, you have a cluster, and then you work on it for a couple hours, you're done, and you say, okay, delete this. Like,
yes.
That was a scary prospect a while back, because you're like, oh, I might have to wait, 2 or 3 hours for the infrastructure to get provisioned for this behind it. At certain providers, we're slower, right? Some are very fast.
And that's where Ardlon comes in. It gives you even a higher layer of it. It tells you that, hey, I will create cluster for you, and I will deploy all apps that you want on top of it. So you just don't have a cluster, you have a fully functional environment, a dev or test environment as a developer. When you come in, you just come in, do a click, 20 minutes down the line, all the cluster, your apps, your whole dev environment is ready. You just get your coffee and you start to work. I mean, that's how easy it is.
Actually, so I can deploy branches, right?
What?
Go ahead.
No, I had one very funny thing. So in one of the hackathons at Platform 9, what one of the engineers did was he used the Google's fencing APIs to detect that he's leaving home and he's moving towards the office, and that would trigger a Slack bot to create his dev environment. So by the time he is in the office, has brought his coffee and whatnot, by the time he's back at his desk, his dev environment is again back up. And again, by the time when he leaves, again, the Google fencing will allow you to say, okay, you're leaving the office area, and let's say you're moving so many minutes away from that area. It tore down his dev environment. So back to a clean state every day.
I think he just needs to add at the end of that an email to his boss how much money he saved every day. Even better.
And look at, if you're a big enterprise servicing 1,000 developers, look at the amount of cost you'll save. I mean, that's incredible.
It is, especially after I managed a couple hundred developers in an environment too, which it gets very spendy very fast. Not thinking about like these clusters because there's VMs behind them. right? You're paying for those VMs, you're paying for networking, you're paying for everything that's going on. So I guess the interesting thing that I was thinking too is like for development like open source, I can use Argo CD to deploy a branch or like a PR that I've pushed to make sure that it works and then test against it, right? Like that's even cooler. So for people that don't already have their own testing infrastructure and stuff up, that could be a suitable use case for them. Any I don't know if you have any comments on that. I'll go to the next thing. So after working with it, I'll go to Anmol first. After working with CAPI and integrating into a product, what features would you like to see added? Like what do you see in the next like 6 months or so, features that could get added that would benefit you and users?
Sure. So I think there's some of the features I would say are the stability in terms of infrastructure provider core components. So let's say there are EKS node groups, right? Managing EKS node managed node groups is a pain for customers today. Like upgrades with CAPI, it becomes easier. So it just might get probably need some more features down there would really help to go on that way. So individual provider specific contributions and the features expansion there would really help. And then and I think that's itself is a huge thing to do because every provider has to support a lot of common features. And then on top of that, you have to do a lot of security and add-on stuff. So if we have a common way of deploying add-ons on top of a Kubernetes cluster in CAPI, that would be incredible. I know there is experimental API that's already out there, but it's not that mature, but the community is working on it. So once that comes in, it will be even more fantastic to use CAPI.
So when you say add-ons, do you mean like services provided by cloud providers that they could like say some of them install their own version of Istio or something like that, like being able to select, hey, I want these add-ons that you support for the Kubernetes cluster installed alongside it? Like, is that what you mean by add-ons or?
Yeah, there are actually two kind of add-ons. One are like your user-specific add-ons. Let's say your Prometheus, Grafana monitoring stack, whatever you want to deploy. That makes your cluster usable and observable. Or you want to deploy any other tool like Argo or any other tool which makes your cluster more usable. That's one kind of add-on, which is not part of Kubernetes cluster, but it's actually part of your environment, right? So that's one part of it. And then there are specialized services given by the infrastructure provider itself, let's say AWS or Azure, where you want to use those services and extensions to those services. So that would also really help there. Yeah.
Awesome. What about you, Pushkar? What would you like to see added? Are there any features or something that you think that it needs that you haven't seen discussion around? Or
Yeah, I mean, as a developer, I would like to see a bit more visibility especially into errors that happen. For example, like something simple like your VPC creation fails, or you have reached your AWS limits. Get those errors, you have to look at the logs of the controllers, and especially for us as a platform, as a SaaS company, that's kind of opaque for the end user of platform line. They don't know how to reach the logs of these controllers, but we do. So for us we have to look at the logs. We understand all of that, but then yes, you have to having those errors reported and bubbled up all the way into the APIs and the status of the object would make life easy even for the end user and developers.
There's a lot of it there, but it needs to get better.
Yeah.
Would that be like a webhook or something like that? They can do checks and stuff before you deploy something to tell you, hey, you're out of infrastructure, and it spits back an error out? Like, because what you're saying on our side is like we go down like 2 or 3 layers to grab that error and pull it back out and give to someone, instead of like I understand like the webhook doesn't just give, like when I try to create something, it won't tell me anything. Like it's not smart enough yet.
I mean, webhooks are one way of doing it, but webhooks are I don't think webhooks can solve something like this personally, because see, it's not just me that's deploying the cluster. It might be 5 different engineers deploying the cluster at the same time, and then you get into all these corner cases of, hey, when I did the check, the resources are there, but later on they're not there. Then there are dependent resources, right? I mean, when you're deploying an AWS cluster, there are like at least 5 to 10 different resources that you'll be creating. And each of those resources have their own dependent resources, like security groups and security group rules inside those security groups. There are IAM policies that might get deployed. So all of these resources not everything is visible, reported as an error all the way to the end user.
What do you mean? I just put my credentials in and stuff works, right? That's everything works. All right, so we're getting close to time, so I'll go ahead and I'll start with Anmol, then I'll end with Pushkar. So, is there anything else you want to share, Anmol, or anything interesting about CAPI that we didn't touch on that you want to say, or?
Yeah, I think I would probably love to talk to our users or anyone watching this and getting their views of what problems they are facing with their infrastructure today, right? In terms of Kubernetes, EKS, AWS, whichever they're using to understand those use cases. And the power of Cluster API is that it's open source, right? So even if it's not there, we can build it into it and we can send proposals to it. So I think that would be one thing. Like the more pain I hear from users, the earlier we can solve it. So that's something for me.
Yeah, it would be very good to actually get more feedback from the end user saying that, okay, this is what we feel is something is missing from CAPI, and yes, we can definitely try to improve that on an engineering front as well.
Was there anything else you want to share, Pushkar, or add on to anything else like about CAPI that we didn't talk about, or something you're excited about or looking forward to with it, or?
Yeah, one of the things is I would really love to have a full-blown bare metal or bare OS. I shouldn't say bare metal. There are already multiple bare metal providers. I want to go. It would be exciting to see a bare OS provider where I have a VM. How do I take it all the way, including add-ons and everything? Everything gets configured all the way into Kubernetes cluster. Yes.
I'm sure we'll get there in the next year. I mean, I'm sure we'll see some. Taking me on to the next thing. I'll say thank you both for your time in the discussion, but take me on the next thing. I'm sure we'll see some presentations at KubeCon talking about similar things to that, right? Maybe people will be talking about that, or if you want to, you can. All right, this is my upsell for KubeCon. Join us at KubeCon. I'll be there. I'll be at the booth the 24th to the 28th. Stop by, pick up a shirt, talk to me about Kubernetes or CAPI or any of that stuff. If you've got some responses for Anmol, send them to me and I'll reach out to them. But you can reach out to us on LinkedIn. You can join our Slack. Let me put that on the overview. You can join us on Slack, slack.platform9.io. I'm in Petersen there. Reach out to us if you want to see a demo or learn more about it. Let us know. That's it. I think that's our show. Thank you both so much for joining us. I hope you had fun, and I had a great time.
Absolutely. Thanks, Greg. It was fun.
Yep. Thank you. All right. I'll see everybody next time.